All right, the last lesson was on simplifying radical expressions. There's more to simplifying radical expressions than what you learned in that last lesson. Let's get into the more. At the top of the screen here, there are two expressions, numerical expressions. The one on the left is considered to be simplified. Remember in the last lesson, we said that you could multiply whole numbers together and get a simplified result. You could multiply radical numbers together, like square root of 2 times square root of 3 is square root of 6. But you cannot multiply a whole number and a radical number and get something simplified. You can't really combine them. If you multiply the whole number 2 times the square root of 3, all you get is 2 square root of 3. Likewise, you cannot divide a whole number and a radical number. The square root of 15 divided by 3, as shown here up on the left, is not 5. It's not the square root of 5. It's just that. It can't be simplified anymore. Okay? Now, the expression on the right, 3 divided by the square root of 15, that's not considered simplified. We have to do things to simplify it. But the simplifying is not what you would expect, because it does not become 1 over 5, and it does not become 1 over the square root of 5 either. Okay? And the reason it's considered not simplified is because simplified radical form means, among the things that we learned in the previous lesson, that we don't ever leave a radical sign in the denominator of a fraction. Okay? A radical sign in the numerator of a fraction, like this first expression here, is acceptable. But in the denominator, no. And so we want to transform the appearance of the fraction until there is no until there is no radical sign in the denominator anymore. Now, if we end up with a radical in the numerator, that's okay. Or if the radical completely goes away, that's okay. We just don't want to have a radical in the denominator. And here's how we deal with that. We're going to multiply the given fraction here by the number 1. Keep in mind, anything times 1 remains unchanged after the multiplication. 3 times 1 is 3. Negative 6 times 1 is negative 6. 2/3 times 1 is 2/3. So I'm going to multiply by 1 because I don't want to change the value of this first fraction. I just want to change how it looks. Okay? And let me give you an example. You're familiar with this process. If we have the fraction 8/12 and we can change how it looks, so that now it looks like 4/6, and even change it even more. 2/3 does not look the same as 8 over 12, but these are all the same value. Okay? So changing the appearance of a fraction is distinct from changing the value of the fraction. We want to maintain the value that was given to us here, but we just want to change how it looks so that there is no radical sign in the denominator. And the way we do that, again, we're going to multiply the number 1, but we're not going to write the number 1, and we're not going to write 1 over 1. We're going to write square root of 15 divided by square root of 15. Okay, which might seem like a really odd choice, but keep in mind that anything divided by itself is 1. Just like anything times 1 is itself, that I illustrated up here, did I say anything times itself? Anything times 1 is itself, and anything divided by itself is equal to 1. 5 divided by 5 is 1. Negative 2 divided by negative 2 is 1. 1.68 divided by 1.68. Anything divided, no matter how complicated it looks, anything divided by itself is 1. So root 15 divided by root 15 is effectively the value 1. Multiplying the original fraction by the value 1 will not change its value then, but it will change how it looks. Remember, when we multiply fractions, we multiply straight across, numerator times numerator. What is 3 times the square root of 15? It's just 3 radical 15. This is why you had to learn what you learned in the last lesson. What is the square root of 15 times the square root of 15? Well, you might be tempted to pull out a calculator and do 15 times 15 and get 225 and write the square root of 225. But then you should check the square root of 225 to see if it's a nice whole number. And guess what? It is. It's the whole number 15. You really shouldn't have to go through all of that button pushing. We talked about this in the last lesson also, right? The square root of the square root of any number is that thing that when you multiply it by itself, you get that number back. So really, you should be able to do this in your head. Root 15 times root 15 is 15. Okay, so now we have an expression equivalent to the original one, but no radical sign in the denominator. So we took care of the radical in the denominator problem. But we have now created an issue that wasn't there at the beginning of the problem. We want this expression completely simplified. Okay, and do you see something here that can be simplified now? Now we have a whole 3 over a whole 15. And so we should reduce that. All right, and 3 over 15 reduces to 1 over 5. But you should not, you're in high school now. You're sophomores, some of you, freshmen, whatever, you're in you should not be writing 1 times anything anymore, ever. Okay, it's not wrong, but you just shouldn't be writing it. Okay, I'm going to mark, if you leave an answer looking like this, I'm going to mark it wrong. Okay, 1 times the square root of 15 is just the square root of 15. That is completely simplified, and it is a simplified version of the original expression. And if you have any doubts at all, you could punch the original expression, 3 divided by square root of 15, in your calculator and look at the decimal form. And then you could plug square root of 15 divided by 5 into your calculator and compare the decimal result to the original. And you would see the decimal digits are exactly the same, right out to the very last digit. Okay. Next one, 10 divided by square root of 2. We're going to multiply by a fraction again, and it's going to be square root of 2 over the square root of 2. Okay. Now, why am I choosing square root of 2 over square root of 2? Why not 5 over 5 or 8 over 8 or square root of 9 over square root of 9? Well, you might have an idea, right? I'm multiplying by the number that's in the denominator of the original expression. That's the number that I'm putting in the numerator and denominator of the fraction that I'm making up. And why am I making that choice? Because that's guaranteed to turn the denominator into a whole number, right? The goal is to get rid of the radical sign in the denominator. And the surest way to do that is to multiply that denominator by itself, okay, to effectively square it. And that will get rid of the square root. So again, multiplying straight across, 10 times the square root of 2 is 10 root 2, and square root of 2 times square root of 2 is 2. Don't circle that until you've thought about whether or not you can simplify that anymore. And we can. The 10 divided by 2 reduces to 5 over 1. 5 root 2 over 1. But you should not be leaving anything over 1 when you get to high school anymore. That's just, honestly, I sometimes wonder if students know if that can be simplified, or if I insisted that they simplify it, if they know what it simplifies to. And that's why I insist that you simplify it all the way. Get rid of that divided by 1. That's totally unnecessary. Okay? And I want to know that you know that. Next one. We're going to multiply by a fraction. And what am I going to put in the numerator and the denominator of the fraction this time? You know, right? It's going to be square root of 3 over square root of 3. And then when we multiply across, straight across, we get 11 square root of 3 over 3. Don't circle that until you have thought about whether that could be simplified anymore. Can it? Well, this time it can't. 11 divided by 3 does not reduce at all. So this is as far as we go. So that's that. And then the last example here, going to multiply by a fraction. Now there's two radical signs in here. Okay, there's one in the numerator and one in the denominator. What are we going to put in the fraction? It's the denominator. The denominator's what we're concerned about. We want to get rid of that radical sign. So we're going to multiply by radical 3 over radical 3. Now, multiplying straight across, what is 12 times square root of 2 times square root of 3? Okay. If you learned from the last lesson how to do this thing, you know what the correct answer is. It's 12 square root of 6, because you can combine the square root of 2 times square root of 3 and get square root of 6. But then the 12 just remains as it is. Square root of 3 times square root of 3 is 3. Can this be simplified more? Yes, it can. 12 divided by 3 is 4. 4 root 6 is the final simplified answer. Okay? And it doesn't really get much more difficult or tricky than that. So let's move on to one other issue. Not only do we not want to leave radical signs in the denominator of a fraction, okay? Remember, the numerator is okay, denominator is not good. Also, we don't leave fractions inside of radical signs, whole entire fractions inside of radical signs. So again, we want to rewrite these expressions, make them look different, not change the value though, but just make them look different so that there is no longer a fraction inside of the radical. We only want whole numbers inside of radicals, not fractions and not really decimals either. Okay. So the first step for this is to turn this into a fraction of 2 square roots. This is a legal numerical step or algebraic step that when you have the square root of a fraction, you can turn that into a fraction of square roots. Okay. And this is just like doing this. Square root of 2 times the square root of 3 is the square root of 2 times 3, which is the square root of 6. Okay. When you have the product of 2 square root signs, like I gave you here, we can turn that into the square root of a product. Well, with division, it's the same thing. When we have the square root of a division, we can turn that into the division of square roots. Okay. Now, square root of 49, you need to recognize is the whole number 7, and the square root of 25 is 5. So there, now we have no more radical sign in the denominator either, because remember, we don't want to leave answers with a radical sign in the denominator. But square root of 25 turns immediately into a whole number 5, which is great. And there is the simplified value of the original expression. Again, if you wanted to bother checking these with the calculator, you put that in your calculator and that in your calculator, you're going to get the exact same thing each time. Okay? So we do the same thing with these other 3. The first step is the same step in all 3 of these. Split it into the fraction of 2 independent square roots. The square root of 16, of course, is 4. The square root of 3 is not a nice whole number. Okay? So I've done some simplifying here, but I still have a radical sign in the denominator. Don't circle that or you don't get the credit. Okay, now we got to do what we did at the top half of this page, which is multiply by square root of 3 over square root of 3. Multiply straight across and you get 4 radical 3 over square root of 3 times the square root of 3 is 3. And that can't be simplified anymore. Okay. Same first step here, split it up into the fraction of separate square roots. Okay, and then square root of 36, come on, you got to know that. This is why I'm sort of drilling into your head what the perfect square numbers are, okay, so that you will recognize them when you see them and turn them instantly into whole numbers. Square root of 36 is 6. You should, if you look at this and you don't realize that square root of 36 is 6, probably what you're going to do is you're going to say, oh, now I need to multiply this by the square root of 36 over the square root of 36. And you're going to turn what is a pretty easy problem to simplify into a much harder problem. Okay, I mean, this wouldn't be wrong, but Good luck to you simplifying your work after taking that step. So this is done. Last one. Square root of 1 over square root of 2. Please, please do not leave the square root of 1 as the square root of 1. That is not simplified. The square root of 1 is 1. Okay, but don't leave your answer like that either, because we got a radical sign in the denominator. So now we multiply by square root of 2 over square root of 2. Multiply straight across. We get square root of 2 in the numerator. Square root of 2 times square root of 2 is a whole number 2 in the denominator. And that doesn't simplify anymore. And we're done. Okay. Read the instructions carefully with each new set of problems on the homework. One of the sets of problems comes with an instruction that says something like this. If you got the last set of problems perfect, then only do the odd numbers in this next set. So read them carefully and check your answers as you go, like it asks you to. Okay, don't do the whole assignment and then check all the answers. Do one set of problems, then it says check the answers. Check the answers. Then go on. Because if you've made some mistakes in the first set, I want you to find out what you did wrong and try to get something straight in your mind before you go on to the next set. Otherwise, you're probably going to continue making mistakes. Okay? So check the answers one set at a time as you go. Bye.